Good morning. Today we're going to continue in Unit 12 with Lesson 6 about permutations. So before we get started, let's do a little bit of review. Finding things like the product. The word product, what does that mean? Do you remember? Product means multiply. And this word is going to be part of our lesson today, so we need to make sure we understand that. So what if we do 20 times 19? Well, yeah, you could use your calculator, but let's see what you remember. We are going to multiply here. We'd get 0, 8, 1, bring down a 0, and then multiply the 1 times everything. 0 and 2. So we would get 380. Then it says find the products of 6, 5, and 4. And again, product means multiply, so we're doing 6 times 5 times 4. So we could write it out vertically if we want, but I'm going to try a different method. I'm going to use our order of operations, and that says that we're going to do multiplication in order from left to right. So if I do this, 6 times 5, I get 30, and then I have 30 times 4, and 30 times 4 is 120. So this would be my answer. All right, so I'm going to give you a challenge, and I'm going to have you pause the video once I give you the word, and you have 1 minute to write as many arrangements of the following word as possible. So for example, if we were looking at the word, if this was your word here, this 4-letter word, one arrangement could be W-R-D-O or D-R-O-W. Okay, so you've got to just rearrange the letters in as many ways as possible. And you're going to have 1 minute. So you're going to have to time yourself. I'm going to pause the video, and then I want you to do 1 minute, see how many words you can write, and then come back and check your answer. This is important, use each letter exactly once. We can't use more than one of the letters. So here's your word. Ready, set, go. All right, your minute is up. Maybe you got these answers, maybe you only got a few of them, but as you can see, I have 4 columns and 1, 2, 3, 4, 5, 6 rows, so there are 24 different ways to write the word stop. Now, some of those don't look like S-T-P-O, that's not a word, but we see that there are some in there, so I have a few questions. How many arrangements did you come up with? Did you get all 24? Or did you come up a little bit short? Did you maybe find 6? Did you find 9? How many did you find? And what strategy did you use? You can see here, I kind of use the strategy of I'm going to keep the first letter in the same spot, and then I'm going to keep the second letter and just switch the 2 that come after it. So I was kind of keeping myself organized that way. I kept my first letter in the columns. How many are real words? Well, let's see, I've got spot's a real word. Well, and stop if we count the original one. Pots and post. Opts is a word. Tops is a word. So it looks like 1, 2, 3, 4, 5, 6 of those are real words. That's kind of cool. Oops. So there are 24 variations. So this kind of is an intro for us talking about permutations today. A permutation is an arrangement of objects in a particular order. For example, we had the original word stop, and it's different from the permutation stop, tops, excuse me. We can see it has all the letters S-T-O-P, but the order is different. So that makes it a permutation of stop. They are permutations because they're different. So find the number of permutations of the letters T-R-I-C-K. So let's see if I do T-R-I-C-K. I'm going to follow my same rule, and I'm going to keep my T first and then change the letters after. So here are a few. This is me just keeping T and R in the same place and only changing the 3 after it. So if I keep going like this, okay, now I've got to do T-I, so I've got R-K-C, T-I-K-C-R, T-I-K-R-C. And about this time, probably some of you are going, oh my goodness, This is the worst thing she's ever made us do. She hates us. I don't hate you guys. And so that's why I'm going to say, like, okay, let me take a second here. If we had the letters H-A-N-D-L-E, so stop had 24 variations with 4 letters. Trick, with just changing the first, like keeping the first letter the same and not even doing all the permutations, we're already up to 1, 2, 3, 4, 5, 6. We're up to 12. And this one has 6 letters, so that's going to be even more permutations. So I'm going to show you a trick. Trick, because that's the word we were changing the permutations of. To find the number of permutations, we can use factorials. So factorial is the product of all the positive integers less than or equal to a number. So if I said find 4 factorial, we use the exclamation point to write factorial. I'm not really sure why. I don't know who decided that that was what we needed to do, but I kind of like it. It makes math exciting. It's like 4. And actually we read this, we don't say 4, we say 4 factorial. But if you want to say 4, that's fine with me. And so 4 factorial would be written as the product, remember that product means multiply, of all the positive integers less than or equal to a number. So I'm going to start with the number that it's equal to, so 4, and then all the positive numbers that come after. Notice we don't go to 0, because if we did times 0, then every single factorial would just be 0. And we don't get into the negative numbers. So 4 times 3 times 2 times 1. Now, actually, let me go back for a second. So stop has 4 letters. So we're saying how many different ways can we arrange 4 letters? If I do 4 factorial, and I get 4 times 3 times 2 times 1, 4 times 3 is 12. 12 times 2 is 24, and 24 times 1 is 24, and that's how many variations we had. So the question here is, how many different ways can you arrange a nickel, a dime, a penny, and a quarter in a row? We've got a nickel worth 5 cents, a dime worth 10, a penny worth 1, and a quarter worth 25. And they're wanting to know how many different ways can you line them up. And so there are 4 coins. So we're going to have 4 factorial. So 4 times 3 times 2 times 1, that's 24. All right, so there are 24 different ways that we can arrange a nickel, a dime, a penny, and a quarter. That seems a lot better than sitting there and trying to rearrange them. Let's look at another one. There are 8 athletes running the 100-meter race. Find the different ways that runners can win first, second, and third. So you've got these 8 runners. And I'm not saying that these are the places that they come in, but maybe they do come in this place. So then you've got one arrangement where 1, 2, and 3 get first, second, and third. You could also have first, third, second. You could have number 8, number 5, and number 3. These are the runner numbers, not the places. You could have runner number 6, runner number 5, runner number 7. I don't know. And there are so many different permutations of this that we're going to use some math. Now, I'm not going to do 8 factorial in its entirety, because if I do 8 factorial, that would be giving me the place for everybody. I want to cut it off right here at after the top 3, because those are the 3 who get medals. So for first place, how many runners can get first place? 8. So I'm going to have 8 runners can get first place, but then somebody gets first. We don't know who. So how many runners are left who could get second place? Well, 1 has already gotten first, so that means that there are 7 runners left who can get second place. How many runners are left to get third? 6. And then we don't really care about 4th through 8th, so we're just going to look at these. So here we're going to have 8 times 7, which is 56 times 6. And then when we do 56 times 6, we should get 336. So there are 336 ways that 8 athletes can come in first, second, and third. I bet you're glad now I'm not making you write them all out. All right, so how many ways can 3 blocks with the letters X, Y, and Z be arranged? If you need to draw a picture to help you see what's happening, helps me. We've got 3 blocks being rearranged. Pause the video and see if you can figure it out. All right, so this time we're rearranging all the blocks, so we're going to say, okay, that's 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. So there are 6 ways. And I want to go back for a second and clarify something. This doesn't look like a factorial because we didn't do 8 factorial. 8 factorial would have been 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is the true 8 factorial. And so really what we're doing is we're taking this factorial and saying, okay, we don't really care about these other places. We're just worried about the first 3 values of that factorial. So even though this isn't 8 factorial truly, this is still a permutation. It's still using the concept of factorials. All right, try this one. A box contains 12 different muffins. If 8 people can choose one, in how many ways can they make their choices? So you've got 12 muffins, 8 people choosing, and how many ways can they make their choices? Pause the video, give it a try, and then come back and check your answer. All right, so this is my drawing of 12 muffins. Don't judge, I'm not an art teacher for a reason. So we've got these 12 muffins and 8 people are choosing. Now it's not like everybody's going to reach in at once and grab one. One person's going to walk up and take a muffin. And we don't know which one they're going to take. So they're going to take one. And there are 12 muffins for them to choose from. But then they take one. So we're going to look at the next person. Okay, the next person has 11 muffins to choose from. So they take one. And then the next person has a choice of 10 muffins because 2 of them are gone. So we've got 10 left. So they're going to have 10 muffins to choose from, and they'll take one. And this is going to continue all the way down. We're going to have 9, 8, 7, 6, 5, 4, all the way here. Oop, I think I went too many. Oh, I took the top off the muffin. That's awkward. 1, 2, 3, 4, 5, 6, 7, 8. And this is going to continue. 9, 8, 7, 6, 5. And notice I've got 1, 2, 3, 4, 5, 6, 7, 8 people here. So that's important. Pay attention to how many people are making choices. All right, so I'm going to multiply all these together. Now, rather than doing 12 times 11 and then 12 times 10, or that answer times 10 and then that answer times 9, I'm going to go ahead and just use my calculator. I'm going to do 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5, and I get, are you ready? 19,958,400. This is how many different ways people can choose their muffins. Bet you're really glad now that I'm not making you do this by hand. That is not your homework, sorry. So head on over to Google Classroom and check out your assignment for today. Let me know if you have any questions.